Hello participants, now I will discuss on lecture 41. This lecture 41 is on sprinkler irrigation system design. In previous lecture, we discussed on importance of sprinkler irrigation system. We discussed about different types of sprinkler irrigation system, and then what are the different parameters which are considered in sprinkler irrigation system. When we want to install a sprinkler irrigation system, we need to have full knowledge about the area and then the resources which are available there, so that this system is installed, designed and installed in the field, and we can get best performance out of this. So, in this lecture 41, this is on sprinkler irrigation system design. We will be talking about sprinkler system hydraulics. We will discuss about what are the different parameters which are required for the design of a sprinkler irrigation system. Basic aim of the design of sprinkler irrigation system is to apply uniform depth of water to the whole field. In surface irrigation method, even if we are trying our best, but when water flows over the land surface, the water which is at the upstream end of the field, it receives water for longer period. So, it gets more time for infiltration. By the time waterfront it advances to the downstream end. So, we talk of uniform depth of irrigation water to apply in surface irrigation system, it is just impossible. Here in case of sprinkler irrigation system, it is possible to apply uniform depth of water all throughout field. This is the main aim. We wish to apply desired rate of application of water, means precipitation intensity it should be at per the desired application rate, means it should not be more than the infiltration capacity of the soil. It should be exactly matching with the infiltration rate of the soil. Second part, the breakup of sprinkler jet, which converts to the droplet size, that causes the deterioration of soil structure and that seals the surface. So, sealing of the surface is not desired, it makes compactness, it does not require. So, it is possible to bring down the water droplets in a desired size if we choose adequate pressure, if we choose appropriate size of the sprinkler nozzle. The efficiency desired to reduce energy requirement in operating system and to maximize the area of coverage. This is another point. If the system is designed properly, we have to choose, or we will get horsepower of the pump, which will require lesser energy, lesser power requirement, lesser fuel consumption. So, this way the energy requirement is reduced and more, and also we will achieve higher system efficiency. Now, the different steps involved for the design of sprinkler irrigation system. So, the number one is stated here, inventory of resources. Now, inventory of resources means how much is the land where we need to give irrigation, how much is the water available. So, whether it is of adequate quantity, what is the source of water, is it a groundwater, is it surface water, it is a pond water, it is a flowing river, stream water, and then the type of power source available, whether we are using electrical energy, whether we are using the diesel operated pump, or we are using alternative sources of energy. Maybe it is solar panel, solar system we are using, or we are using the wind energy. So, this is falling very much under the inventory of resources. The land which we want to cultivate and bring under irrigation, then how is the topography of that land. So, area is to be surveyed, the topography, elevation in the field at all the points where the irrigation is to be given. We need to supply water, whether it is at the highest point, and that particular point is to be considered while we are designing the system. So, that the water it reaches at the highest point, and this point when we are considering that elevation will be considered while we are laying the lateral system. So, this will help in the designing of the system. So, topography map of the area is one of the important component. Soil here, what type of soil it is? Is it a fine textured soil, means clayey soil, more of the clay content? Is it the coarse textured soil like sandy soil? So, infiltration rate of these soils are considered while we are allowing the water to fall over the ground surface. So, soil texture, soil structure, and then nutrient aspect of the soil is also equally important. Whether we need to apply some certain chemicals along with the irrigation water for the so this part also we need to consider. Then source of water, as I told you, that what is the source, surface water, groundwater, quantity, whether the how much amount of water which is available. Accordingly, we will plan to apply for irrigation purpose. And then quality of water, quality is equally important, whether it needs treatment before it is brought for irrigation. So, quality, or it is a sediment laden water. So, before it is introduced to the sprinkler irrigation system, we need to apply gravity system, or we need to apply adequate filtration system before it is brought for irrigation. So, there are different ways to analyze the water quality, which already I have discussed in the water quality part. So, we will discuss about this part. Then quantity of water to be applied. One is the quantity of water available in the first point I discussed. Second point, how much is the demand. So, demand will be worked out after knowing the evapotranspiration requirement of the crop. Now, ET of the crop will depend upon the which season crop is being grown. Is it a summer month? Is it winter month? Is it rainy season? So, this is going to affect the evapotranspiration requirement of the crop, and also the depending on the type of soil and then the sensitiveness of the crop, the irrigation schedule will be prepared. Now, water which is coming out of the sprinkler nozzle. So, because it is a rotating edge sprinkler nozzle. So, it is a forming a circular circle. So, the maximum coverage is attained when the jet coming out of the sprinkler nozzle is at the angle between 30 to 32 degree above the horizontal, and normally 30 degree is used for rotating edge sprinkler system. The empirical relationship to obtain the radius of weighted area, this can be estimated by using the expression r equal to 1.35 root 2 g h. So, this can be obtained empirically, while we will conduct experiment on performance evaluation part. You will also find out what is the radius of coverage. A typical sprinkler system, when it is sprinklers are laid or connected with the lateral. So, you can see here this is one lateral. Now, this lateral is connected, this part let us see in here a water is taken from some source with the help of pump, and it is supplied by using a main line, and on this main line the laterals are attached. One lateral is here, another lateral is here, and then laterals are moved forward. So, when sprinkler is operating, it forms certain percentage of overlap. So, this is the typical water distribution pattern from a single sprinkler. Now, the another sprinkler which is kept at a certain spacing, let us say it is at 50% of the diameter of coverage, the another sprinkler is kept. So, the weighting is formed by the second sprinkler. So, this is the common area. So, the water which will be received at this part of the circle, it will be the water which is distributed by this sprinkler, and also water distributed by the second sprinkler. And this part what you are seeing, there are means here again you are what we are seeing here at this particular place, the water is being received by 3 sprinklers. Such type of overlap will occur. So, a single sprinkler, when the water is being distributed, you see how the weighting means soil moisture movement from a single sprinkler, it will look like. So, more water is available beneath the sprinkler head. A discharge of the sprinkler nozzle is estimated by this equation, Q equal to coefficient of discharge multiplied by area of the nozzle into root 2 g h. This is the velocity head. This part is the velocity component. This is velocity component, not velocity. This is velocity component. Area multiplied by velocity. So, h is the operating pressure, that is the pressure available at the nozzle. So, this way we will calculate one can get how much is the discharge from a single nozzle. Now, the discharge from the single nozzle means it will depend upon the how much is the diameter of coverage. Selection of sprinkler will depend on the what is the diameter of coverage, what is the pressure available, means nozzle pressure, because this is your H which is given, and then how much is the discharge coming out of the sprinkler, which is a function of H, and of course, wind condition. This is also that whether wind in that particular place, it is a calm wind place or it is in the the coastal zone where wind is a major problem. So, one has to use these units to get the discharge from this, and the selection is made by considering these points. Now, when we come to the design of laterals, lateral receives water from the main pipeline and also from the sub main pipeline, and then on the lateral risers, and above the riser sprinkler heads are mounted. So, means sprinkler lateral is connected to the main, or if it is a very large area, there can be manifold, and then on the lateral risers, riser is a smaller pipeline which is placed over the sprinkler, and then on the riser pipeline sprinkler nozzle is mounted. Now, design capacity of the sprinkler on a lateral is based on the average operating pressure. This is where we are taking care that what is the operating pressure which is available on the sprinkler. So, if we want to find out, first of all we will find out what is the average operating pressure in the sprinkler system. So, here the means the lateral is we need to take care the frictional loss in the lateral pipeline is 20% of the average operating pressure. So, average operating pressure you can see here, it can be estimated by the pressure at the farthest sprinkler. Now, let us see, this is the case. There is a main pipeline which is perpendicular to the board, you can see here, and on this main pipeline is receiving water from the pump, and then on the main pipeline the lateral has been attached. In this particular figure, what we are seeing that the lateral is kept at certain elevation, means it is going up the hill. The pressure profile, it is lateral is laid up the hill, means it is on the elevated land, and on this lateral sprinklers are mounted. So, sprinkler, this is one sprinkler, and on we means this is one riser pipeline, and on this riser pipeline the sprinkler nozzles are mounted. Now, you see this is the last sprinkler, and at this last sprinkler the pressure available is H naught. This is the H naught pressure, and somewhere the average pressure means we are measuring it somewhere at this point, that is means not exactly at the end of the pipeline, but we are considering somewhere at the 25% of the distance at from the extreme end, and this average pressure is measured. So, this is given by H A, that is the average pressure. So, H naught equal to 25% of the head loss due to friction. Now, if the means if we are considering, suppose this lateral where it is placed here on the elevated, but if it is this particular lateral is on the level land. So, what will happen? The pressure available in the main pipeline, means what will be the pressure available in the main pipeline? It will be the the pressure required at the last sprinkler plus head loss due to friction. So, head means the H A at the means your average pressure at the end of the, that will be given by H naught plus H f. Now, design of the lateral, what we are doing here, we are substituting, let me just tell you that we are substituting the, we can write here the the H naught, we can write this expression H naught equal to H A minus 1 by 4 H F, means we can write here the value of H naught. So, this can be given by, so we are substituting H n, that is the head, means the H n can be, means we are substituting the value H A plus 3 by 4 H F plus minus 3 by 4 H E. This is H E, that is the head due to elevation, this is due to head due to elevation, and H R is the height of the riser pipeline. So, this particular expression, it is taking care of the average pressure, it is taking care of the head loss due to friction, and then plus minus 3 by 4 H E, this is here it is a H E, that is the elevation. So, elevation is the, means the head at the elevation, it is, you can see here the maximum difference in the elevation between the first and the last sprinkler. Let me just show you the diagram here. This is the first sprinkler on this one. So, what is the elevation, means suppose sprinkler is somewhere here and this last sprinkler. So, this is the elevation difference, that is H E. Now, 3 by 4 H E, because we are taking at this particular place. So, we are putting it 3 by 4 plus minus 3 by 4 H E, because at this point we are considering. So, we have taken here 0.3, this is plus minus 3 by 4 E. Now, plus means there is a, what happened then when the sprinkler lateral is running uphill. So, this we will consider, So, here the H A means this is your the value, that is average head at the sprinkler, H naught is the pressure at the farthest end of the sprinkler, and H n is the head at the main, this is your H n. H f is the head loss due to friction in the lateral, H e as I told you, this is the elevation difference, and H r is the height of the riser pipeline. This H r is the height of the riser pipeline, means this pipeline, if here it is given H r, that is the height of the riser, this is the riser pipeline. So, this has been added. Now, if suppose the riser, if suppose we are not putting riser in the lateral itself, these sprinkler nozzles are attached, then H r will be equal to 0. So, by solving the equation of for means we are putting it H naught has been this H naught is written in terms of H A, and then H n can be written like this. 3 by 4 H E is positive when the lateral is running up the hill, and it is negative when it is down the slope. So, this would be 3 by 4 H E. Now, size of the main pipeline, the size of main pipeline, it is a function of rate of flow and frictional losses. The diameter of the main pipeline is selected such that the normal, the means water application cost is low. Means the size of the main pipeline, what happened, because main is supplying water to the laterals. So, depending on the number of laterals, it is receiving water from the lateral. So, each one lateral. So, multiplied by the number of lateral. So, that will be the discharge from a single lateral, that will be considered and discharge from the multiple lateral. So, this particular lateral should take the total flow. So, here it is the another part, that is one has to optimize that how many number of laterals that can be operated. If we take all laterals to operate at simultaneously, then the size of the pipeline will be large, and then the head loss due to friction will be computed in the same manner as we are calculating in case of lateral. So, here we will be taking same case. Now, normally head loss in the main is taken as a 3 meter, means head loss due to friction is taken as a 3 meter for a smaller system, particularly for our Indian land holding. So, it is 3 meter is considered as a head loss due to friction, but one has to calculate, and then 12 meter is the length, means the head loss due to friction. It is considered for a very large farm, where the large area it is being used for cultivation of the crop. The next part is height of sprinkler riser pipeline. When we are considering height of the sprinkler riser pipes, sprinklers are located just above the crop to be irrigated. Therefore, height of the riser will depend on the height of the crop, means the water which is emerging out of the sprinkler nozzle, it should not be interfered by the crop. So, the height of riser pipe should be above the crop, and then particularly some crops, some plantation it interfere, then we need to raise the height of the riser pipe such that such riser pipe should be provided with the tripod, so that it remain stable, it does not fall when water is being supplied by the riser pipe to the sprinkler nozzle, because it is a vibrating. So, it should be properly erected by putting the tripod. To avoid excessive turbulence in the riser pipe, minimum length normally 30 centimeter or even 1 meter, that is 1 means of 25 millimeter diameter, that is used. So, 30 millimeter for the smaller crops, 30 centimeter for the smaller crop, but for the crops like sugar cane it should be large. But normally these pipelines, riser pipeline on the sprinkler is of 1 meter in size. In sprinkler spacing, that means sprinkler spacing, the sprinklers distribution uniformity depends on the operating pressure, wind velocity, rotation of sprinkler, and spacing between the sprinklers and laterals. So, spacing is the another part that has to be taken, that is how much is the pressure, and then what is the wind speed, and then the spacing between the sprinklers on the lateral, spacing of the laterals also means the spacing of the sprinklers along the lateral, that is also taken care. Adjustment of this sprinkler and spacing should be made, or there should be provision so as to achieve maximum uniformity. In general, the depth of water near the sprinkler is more and gradually is decreases as when we the sprinkler jet it goes out of the circle, means outer circle. So, while we decide the sprinkler spacing, one important point is wind speed. It affects the the water distribution pattern. So, overlapping is provided in order to get better uniformity. So, overlapping of spray pattern of the individual sprinkler is required to get the uniform depth of water coverage. So, here you can see when there is no wind. So, the spacing is of 65% of the water sprayed area is given. When the wind speed is 0 to 6 kilometer per hour, 60% of water sprayed area, 6.5 to 13, 50%, and then greater than 13 kilometer, this is 30% of the water sprayed. Means as the wind speed increases, the spacing between the sprinkler it decreases. So, there is a more closure. So, arrangement of the sprinkler is done so as to increase the water sprayed area overlap. But if there is a wind of considerable speed, the spacing between sprinkler get reduced. Now, sprinkler discharge considering the area of coverage. So, selection depends on the weighted diameter of the nozzle due to nozzle at a given operating pressure nozzle, and then combination of sprinkler spacing, lateral moves and application rate suiting to the soil and wind condition. The required discharge of an individual sprinkler is a function of water application rate and two-way spacing of the sprinkler. Two-way here, spacing of sprinkler along the lateral, spacing of the sprinkler along the main. So, a discharge from a individual sprinkler is given by the area of. So, this area is computed, that is S L into S M multiplied by the application rate. Now, 3600 is the unit constant. So, depending on the type of unit which we are using, if it is in means I application rate is millimeter per hour and S L is the spacing of sprinklers along the lateral is S L, and S M is the means spacing of the laterals along the main, or spacing of the sprinklers along the main. That way also it can be told. The same thing which I told here, that the application rate it is to be given in such a way that it does not form runoff, and so application rate will depend upon the particular type of soil texture and the depth of soil. It will also depend upon the land slope, prevailing land slope. So, the soil texture is a coarse soil, means if it is say let us say coarse sandy soil, and then application rate it is in given in 5.1 millimeter per hour. As we keep on reducing the size means your texture means of the soil or the soil particle, it is reducing, means when coming to the very fine texture soil, the application rate it is decreasing. So, this is the purpose. It is explained here that while we are selecting a particular type of application rate, we need to see that what is the application rate. Here the another table it has been provided. The slope is one part, and also the type of soil, and then the above land surface. So, means this will be these are the means values based on the infiltration capacity of the soil. Based on that it has been decided. So, if you can see here, the units are in inch per hour. This unit is in inch per hour, and these are the prevailing land slope. So, if it is a say soil surface is not protected, means bare land, we can say bare land, but if it is a light sandy soil For bare land, the application rate is 0.5 to 0.75% for the land slope in the range of 0 to 5%. For the same soil, you can see when there is a residue or heavy grass cover, the application rate can be increased for the given same slope. And then for the same slope, when you see with the different soil texture without the means, so it is a medium texture soil with sandy loam, fine sandy loam and silt loam, this is the range. And then for heavy texture, that is a clay type of a soil, that is 0.1 to 0.25. So, this way one has to decide the value. So, the equation which I was telling you, Q equal to S m into S L multiplied by I divided by 3600. So, these values has to be chosen, and this is, since it is in inches per hour. So, this will be multiplied and brought in the terms of millimeter per hour. So, that value can be used. The capacity of the sprinkler system means one has to decide what should be the discharge capacity of the pump. So, this discharge capacity of the pump will depend upon the how much area to be irrigated and what should be the depth of irrigation, and then number of operating hours. So, area in hectare means when we are expressing Q in liter per second. So, area cropped area in hectare, depth of water application in centimeter, and then what is the irrigation interval, means how many days the one irrigation cycle will be completed, and number of hours the system is operating, and then water application efficiency. So, having got this value, one can find out the system capacity. Now, this system capacity can be matched with the total the discharge a main line has to handle. Now, I have given you in the previous in this particular slide where I talked about the head loss due to friction. If you see this particular slide where head loss due to friction has come. Now, this head loss due to friction can be estimated, just I estimated by any one of those three equations, and which has been explained in the design of drip irrigation system. So, this is a generalized equation where head loss due to friction can be computed by using this equation, where K is a unit constant, C is another constant of that is to be used for a particular equation, L is the length of the lateral or pipeline you can say, and Q is the discharge to be handled by the pipeline. It could be lateral pipeline, it can be main pipeline, it can be sub main pipeline, and D is the diameter of the pipeline, and this capital F is the reduction factor. This capital F is the reduction factor. So, reduction factor already we have discussed, and depending on the type of unit which we are putting it, one can use a particular value of the reduction factor. So, but one can use the particular value of constant. So, let us say that small c which is there for Darcy-Weisbach equation. So, 2 4 times 7 8, then L is the length of the pipeline, and m will be in case of Darcy-Weisbach equation. If I am using the metric means SI unit, then this is m equal to 2, and n if I am taking the Darcy-Weisbach equation, this is 1, and the d is the diameter in millimeter. Accordingly, the value of the and k is the particular unit constant. So, that k will of course has to be obtained by using appropriate expression. Say in case of Darcy-Weisbach equation, we will be using this equation, and f is to be obtained from the Moody diagram, and this is for the Hazen-Williams equation, this is for the Scobie formula. So, accordingly the value of the K will be obtained. Now, to find out the what will be the head which will be required for the pump to operate. So, this total head against which the pump will operate will be the head required, that is H n at the main pipeline, and then this is the total frictional head loss from the main pipeline, and H j, that is the so let us see that this is the elevation difference between the pump and junction of the lateral. H n is the maximum head required at the main to operate the sprinkler nozzle at required average pressure, including the height of the riser pipeline. H s is the suction head, that is the elevation difference between the pump and then source of water. Now, having got the value of total head requirement, this can be expressed, the power requirement in kilowatt can be expressed by 9.8 into the discharge, that is a Q which we require to operate the main pipeline. So, this is the total discharge in meter cube per second, and this H t just now which I told that this is the total head requirement, and E p is the pump efficiency. So, this is the pump power. Now, this pump power can be expressed as in the terms of horsepower, that is means kilowatt divided by 0.746. So, this will give the, now if the pump is driven by a prime mover and this prime mover has efficiency of some certain efficiency, then horsepower of the pump can be given by this your kW by 0.746 multiplied by the efficiency of the drive efficiency. So, you may refer these reference material for this particular topic, and then let us try to summarize the whole lecture. We discussed about different design parameters, we discussed about the hydraulics of flow through the lateral pipeline, hydraulics of flow through the main pipeline, and then total the how the water is the water horsepower, pump horsepower can be estimated. Now, in the forthcoming lecture we will discuss about evaluation of a sprinkler irrigation system. Thank you very much.